Hello student, welcome to the lecture. In this lecture we are going to discuss the assumptions and aspects of valence bond theory. In previous lecture we discussed the introduction and why there is a need of hybridization and how the hybridization on the basis of hybridization covalent bonding is formed. So in this lecture we are going to discuss the aspects of valence bond theory. So on the basis of atomic orbital, explain the possible bonding and hybridization of molecule, possible bonding and hybridization of molecule in complexes. Electronic configuration of molecule in complexes in ground and excited state also. Combining and mixing of orbital gives rise to new orbital. With equivalent energy. Now the next one, interaction of hybrid orbitals with ligand orbitals results in bond or form the bond. Now next one, explanation of shape of molecule on the basis of hybridization. Also, the magnetic properties of the complexes will be decided by this theory. And we can write here explanation of magnetic properties of molecule in complexes. So these are the all aspects which cover these are all aspects what's covered by the Pauline's valence bond theory. Now on this aspect he deduced some assumptions. What are they? Let's see. Now let's discuss assumptions are valence bond theory. Now let's discuss the first assumption. Number of vacant atomic orbital is must be equal to the coordination number. So the first assumption is that the number of vacant orbital is equal to its coordination number. Means that now the number of vacant orbitals means its found number of bond, and the number of bond forming means the number of ligand orbital attached to the central metal atom, means there is a coordination number. Thus the metal atom or ion make desired number of vacant orbital. Donor atom, a donor group means that is a ligand, or donor group must have at least have one sigma type atomic orbital containing one lone pair of electron a full ligand orbital containing vacant orbital overlap vacant orbital of ligand to form sigma covalent coordinate bond. Addition to sigma bonding, pi bonding may result in back bonding. Back bonding means metal to ligand bonding. To filled metal orbital to vacant ligand orbital. These are all the general assumptions of valence bond theory. Now let's discuss what is the structure and magnetic moment on the basis of VBT, that is valence bond theory. Structure and magnetic moment. The transition metal compounds are paramagnetic due to presence of unpaired electron. Means that if there is the transition metal containing unpaired electron is known as paramagnetic. And the transition metal containing and the transition metal containing no any unpaired electron. Electron is known as a dimagnetic. And here we can write paramagnetic and dimagnetic. If the compound is paramagnetic, then mu value, that is magnetic moment, is greater than 0. And here means it is a magnetic moment, that is stand for magnetic moment. Mu value is 0. It is a diamagnetic. So here this mu are nothing but magnetic moment. Is calculated by spin only formula. Spin only formula. The magnetic moment is number of unpaired electron. So this is the general formula for the calculation of magnetic moment, that is mu is 0, that is n plus 2 in under root n plus 2, where n is the number of unpaired electron. Now let's discuss how this magnetic moment or the apply to the complexes. To discuss the silver complexes, that is diamine silver complex. Here let's discuss the hybridization and the magnetic moment of this silver, that is 5s1 and 4d10. Here 5s0 and 5d. There will be the two ammonia ligand and there will be the two vacant orbital need to enter the ammonia orbital with the metal orbital with electronic configuration. So here that is (3d10). So there is a no in a vacant, then there is a 4s and 4p orbital. So for the entering of two ammonia molecule, it will be required the two vacant orbital. So that is 4s and 4p. Means that this two vacant orbital, one orbital of 4s and only one orbital from 4p orbital will be required for sp hybridization. As we know that the shape of orbital, that is s orbital is a spherical, p orbital is a dumbbell shape and d orbital is again double dumbbell shape. Number of ammonia molecule required for this entering these two orbital. So there will be discussed, that is silver what happened here. Let's see. that is 4p, and that is 1 4s and 4p. So this is a NH3 ligand. This is a 2 NH3 ligand entering in this orbital. So that is 1 s orbital and 1 orbital from p, that is p. Position is there, and the structure is as like that is if you observe, there is no any unpaired electron is there. So that's why this is a diamagnetic. Where for diamagnetic we know that the magnetic moment is 0. So here diamagnetic and magnetic moment is 0 for this silver. Now let's discuss the next one. Configuration, that is of nickel, that is we know the 18 number, that is 4s0, 4s2, 3d8 nickel, that is +2 here. So that is 4s0, 3d8. For entering of 4 chlorine, there will be requirement of 4 vacant orbital. So for nickel +2 complex, it will be here, that is 4s orbital, and that is 4p1. That is here there will be the 4 chlorine atom is entering in that orbital. So the hybridization is become sp3 hybridization. Here actually what happened, the electrons are not entering in this d orbital because chlorine is a weak field ligand and it not enter directly into d. It will be just entering the outermost orbital, that is 4s and 4p, and it form the sp3 hybridization. So the number of unpaired electron here, that is the number of unpaired electron here is the number of unpaired electron is 2. And mu is a 2.38 bm, that is Bohr magneton. So here actually the Bohr magneton is depend upon the number of unpaired electron. How many unpaired electron is there is become the magnetic moment of that respective complexes. Here there is a 2 electrons, so the approximately the magnetic moment is related with the 2.38 or something. Means 2 there is a magnetic electron, sorry, the magnetic moment is equal to the number of electron I just tell that. So here there will be the 2 unpaired electrons, so the magnetic moment 2, the complex that is a paramagnetic one because unpaired electron, and the shape of molecule, that is the shape is a tetrahedral one. So this is a general magnetic moment, number of unpaired electron, and the shape of the molecule. Now we will stop here. In next lecture we are going to discuss the next one.